Welcome to this comprehensive exploration of alkaloids, a fascinating and chemically diverse group of naturally occurring organic compounds that have intrigued scientists for centuries. Alkaloids, characterized primarily by the presence of nitrogen atoms, usually within heterocyclic systems, represent one of the most functionally significant classes of natural products. Found abundantly across the plant kingdom and in certain fungi, animals, and microorganisms, alkaloids have shaped not only the trajectory of organic and medicinal chemistry, but also the development of modern pharmacology and agriculture. In this video, we will delve deeply into the chemical nature, biosynthetic origins, classification, physiological activities, and applications of alkaloids, exploring their duality as both potent toxins and invaluable medicines. Alkaloids exhibit immense structural diversity, yet their unifying feature remains the incorporation of basic nitrogen atoms, typically in amine or heterocyclic forms. This structural motif imparts notable physiological activity, largely attributed to their ability to interact with biological macromolecules, such as receptors, enzymes, and nucleic acids. Chemically, alkaloids span from simple, low molecular weight compounds like nicotine and choline to complex polycyclic structures such as the indole alkaloid vinblastine or the isoquinoline alkaloid morphine. Their basicity, generally resulting from the lone pair electrons on nitrogen atoms, governs their solubility behavior, often favoring extraction into acidic, aqueous phases during isolation. It is this same nitrogen that facilitates hydrogen bonding and pi stacking interactions with biological targets, thereby underpinning their wide-ranging pharmacological actions. The biosynthetic pathways of alkaloids elegantly demonstrate nature's capacity for molecular innovation. They are primarily derived from amino acids such as ornithine, lysine, tyrosine, tryptophan, and phenylalanine, with additional modifications including methylation, hydroxylation, and oxidative coupling. For example, biosynthesis of morphine begins with amino acid L-tyrosine in papaver. In a multi-step pathway, synthesis proceeds through the 1-benzioisoquinoline backbone, with S-norcochlorine playing a pivotal role. Plants remain the predominant producers of alkaloids, utilizing them as defensive chemicals against herbivores and pathogens. However, microbial sources, particularly actinomycetes and endophytic fungi, have increasingly garnered attention for their unique alkaloid profiles, highlighting the ecological role of these compounds as chemical mediators in complex symbiotic relationships. Alkaloids are systematically classified based on their biosynthetic precursors or structural types. The major classes include pyridine and piperidine alkaloids, such as nicotine and choline, known for their neuroactivity. Tropane alkaloids, including atropine and cocaine, which exert profound effects on the central nervous system. Quinoline and isoquinoline alkaloids, represented by quinine and morphine, noted for their anti-malarial and analgesic properties respectively. Indole alkaloids such as reserpine and vinblastine, which are potent antihypertensives and anti-cancer agents. Imidazole alkaloids like pilocarpine, used clinically to treat glaucoma. Purine alkaloids such as caffeine and theobromine, ubiquitous stimulants affecting adenosine receptors. Each of these classes encompasses compounds with highly specialized biological roles, often reflecting intricate evolutionary pressures and ecological adaptations. Historically, alkaloids have served as both medicinal agents and poisons. Their strong physiological effects stem from their capacity to modulate key neurotransmitter systems, enzyme activities, or ion channels. Morphine, for instance, remains one of the most potent analgesics, acting primarily through opioid receptors to suppress pain signals. Similarly, atropine is indispensable in anesthesiology and ophthalmology due to its anticholinergic effects. However, the toxicity of certain alkaloids cannot be understated. Compounds like strychnine and aconitine act on the central nervous system with lethal consequences in even small doses. Thus, the clinical use of alkaloids demands precise dosing and rigorous safety evaluations. Modern drug development continues to draw heavily from alkaloid scaffolds, with many semi-synthetic derivatives demonstrating improved therapeutic indices. Isolation of alkaloids from natural sources typically involves extraction with organic solvents, followed by acid-base partitioning, chromatography, and crystallization. Techniques such as high-performance liquid chromatography, HPLC, gas chromatography mass spectrometry, GCMS, and nuclear magnetic resonance NMR spectroscopy play pivotal roles in structural elucidation. While many alkaloids are still obtained from their native sources due to complex stereochemistry and challenging total syntheses, advances in synthetic organic chemistry and biocatalysis have yielded efficient routes for the preparation of numerous alkaloids and their analogues. In particular, the advent of biomimetic synthesis, emulating the enzyme-catalyzed steps in alkaloid biosynthesis, has unlocked new avenues for the production of structurally intricate alkaloids with high selectivity. Beyond medicine, alkaloids are widely applied in agriculture, veterinary medicine, and even in material science. For instance, nicotine derivatives serve as potent insecticides, while certain indole alkaloids are used in veterinary sedatives. In food and beverage industries, alkaloids such as caffeine and theobromine remain integral to products consumed globally. Additionally, researchers are exploring alkaloid-derived polymers and supramolecular assemblies for advanced material applications, leveraging their unique functional group architectures and chiral frameworks. In the era of green chemistry, there is also a growing interest in exploiting alkaloids as renewable, bio-based starting materials for fine chemicals. In summary, alkaloids occupy a singular niche at the interface of chemistry, biology, and medicine. Their structural diversity, combined with profound pharmacological effects, has positioned them as both powerful therapeutic agents and valuable chemical tools for fundamental research. As our understanding of biosynthetic pathways deepens, and as synthetic biology and metabolic engineering mature, we can anticipate a new era of discovery, where both naturally occurring and artificially designed alkaloids reshape the boundaries of pharmaceutical and chemical innovation. Thank you for joining this in-depth exploration of alkaloids. We hope this journey has not only enriched your appreciation for these remarkable molecules, but also sparked curiosity about the untapped potential that still lies within nature's chemical arsenal.